The Speed Demons, a group of ragtag kids inheriting the mantle of the first-generation Bellbrook drone engineers, has come together to put the pedal to the metal. Though our journey has been fraught with peril and uncertainty, our multi-talented and diverse team has managed to produce a drone design and compete with other teams to try and get to the top of the brackets.
When creating the logo, we wanted it to look more professional, but yet represent our bold and daring team and really help us stand out from the rest. We decided that we wanted it to be associated with some kind of fire design to help tie in the demon part of our name and to further represent our team characteristics. At one point, we made sketches of a demon character, but we decided to scrap it to keep the design more simple and sleek. We went with a sharp font to better convey our team's adventuresome characteristics and to tie in the theme of speed.
The marketing department has also worked to cultivate relationships with local businesses in order to get funding. In the fall, we partnered with Chipotle in a dine out which raised funds for both competing Bellbrook teams. We will be cooperating with them for another dine out later this month. Following into January, marketing was also able to agree to a sponsorship deal with Select Tech Geospatial, who graciously provided a drone carrying case and funds to continue our activity. We were also able to get a dine out set up with Chick-fil-A. And lastly, we are finalizing a sponsorship deal with a local Italian place in downtown Bellbrook, Billy's Pasta and Pizza. This is a massive thank you to our sponsors for supporting us throughout our season.
My name is Darius and I am the manufacturing engineer. I also helped with the design process. We used a decision matrix to determine the design of our drone and chose the Flightech Guardian Gremlin V2. The main quality that we liked was its simplicity. We originally based the design very closely on that of the Gremlin, but found it was not optimized for our needs. The largest flaw it had was that it was very heavy. This was a big challenge, especially when it came to designing the base plates. Sam used Autodesk's Inventor Professional to create the base plates in CAD, and I switched them over into Inkscape so they could be understood by the laser cutter. Our original camera mount design was based on the camera mount that was included in the Gremlin kit. It was mounted using a stand-up. We then tested it and realized that it could damage the power cable or VTX antenna, so we decided to design our own. The run cam system required a complete redesign of the camera mount because it uses the central electronics board screws to hold it in place, not a stand-up. For the payload holder, we used a bottom-mounted design using the electronics board mounting screws. We made some changes to it, such as filleting the corners to allow more airflow to reach the propellers, as well as making the mounting holes more accessible. We redesigned it once again to allow for the payload holder to be held better and also hold the battery. Here's our bottom base plate. We laser cut it out of Delrin for its strength. Here's our top base plate, which is laser cut out of hobby grade plywood. We had some failures with it, which we have now fixed, which we tested. Here is our payload holder. It has the battery mount on the top and is printed out of TPU filament for its higher ductility. Here is our camera mount, which is 3D printed out of TPU for the same reason.
The biggest changes we made since our last competition was switching this beam here out for Delrin. It kept on breaking and decided the best course of action was just to make it out of Delrin. We also switched batteries, so that required a rescaling of this part here, which holds the battery in place.
Here you can see us flying the February course with the stock drone. This allows us to practice flying before our drone was ready. Here you can see us flying a drone to test the strength and integration of all the parts. Originally we planned to use the CAD all-in-one camera, the same as what was used on the Gremlin. However, we switched designs after running into issues with ease of changing channels. We pivoted designs and now use the RunCam Nano 3 and the Zeus Nano for a camera and VTX pair. This allows us to change channels using Betaflight and made the channel changing button more accessible. Due to our weight-focused redesign, we had some changes that we needed to make for the materials we used. We switched from PLA to TPU filament for our 3D printed parts, which was chosen for its needed ductility. Also to reduce weight, we decided to move the battery to the bottom. This allows us to take a lot of material away from the top base plate without adding much to the payload holder print.
So we're having some issues with holding the battery in place, so that battery holder will need to be resized correctly for this battery. On the top end, we broke a piece off, which we'll probably thicken.
and we're having connectivity issues with our antenna to our VTX.